What if I told you that right now, at this very moment, something is happening behind our sun that could completely rewrite everything we thought we knew about how our solar system works? And what makes this even more disturbing is that scientists discovered it almost by accident, and they're calling it one of the most anomalous objects ever detected in our cosmic neighborhood. I'm talking about Comet 3I Atlas, but here's the thing that should make your blood run cold. This isn't just any comet. The I in its name stands for interstellar, meaning this object came from outside our solar system, traveled across the incomprehensible void between stars, and is now doing something behind the sun that's making astronomers lose sleep at night. And the weirdest part? The data suggests it might not be behaving like a comet at all. On March 3, 2025, Dr. Sarah Rabis at the European Southern Observatory noticed something in the data that made her call an emergency meeting with her colleagues. The light curves weren't matching any known model. The trajectory was wrong. The outgassing patterns defied explanation. And when they triangulated its position, they realized it was performing maneuvers that natural objects simply shouldn't be capable of. But here's what will absolutely blow your mind. For the next 230 minutes, I'm going to take you on a journey that will completely transform how you see our place in the universe. Because 3I Atlas isn't just challenging our understanding of comets. It's challenging our understanding of what's possible, what's natural, and what might be watching us from the darkness between the stars. Before we dive into this rabbit hole together, do me a favor, hit that like button and subscribe, because YouTube's algorithm needs to know that people care about real mysteries, not just clickbait. And drop a comment telling me what country you're watching from and what time it is where you are. I want to see how far across this planet this information spreads. Because trust me, by the end of this video, you're going to want to share this with everyone you know. Let's start with what we think we know about comets. Because before we can understand why 3I Atlas is so bizarre, you need to understand what normal looks like. And I promise you, even the normal stuff about comets is going to surprise you. Most people think comets are just dirty snowballs floating through space. That's what I learned in school, and it's probably what you learned too. But here's the first twist. Comets are actually more like ancient time capsules, frozen libraries containing the original ingredients of our solar system from 4.6 billion years ago. Every comet is a messenger from the birth of our cosmic neighborhood, carrying pristine samples of the primordial material that existed before Earth, before life, before everything you've ever known. Think of it like this. Imagine you found a sealed jar in your great-great-great-grandmother's attic containing food from 150 years ago. That jar would tell you about farming techniques, preservation methods, and ingredients available in that era. Now multiply that backwards by about 30 million times, and you start to understand what comets represent. They're not just space rocks. They're archaeological artifacts from the universe's childhood. But here's where it gets interesting. In 2017, something unprecedented happened. Hawaiian astronomer Robert Warwick was analyzing routine telescope data when he spotted something that shouldn't exist. Oumuamua, the first confirmed interstellar object to pass through our solar system. The name means scout or messenger in Hawaiian, and let me tell you, that name turned out to be more appropriate than anyone realized. Oumuamua was weird from the start. Its shape was elongated, possibly cigar-shaped or disc-like, unlike any natural object we'd seen. But here's what made scientists truly uncomfortable. As it was leaving our solar system, it accelerated. Not because of gravity, not because of reflected sunlight pressure alone. It just sped up. Dr. Avi Loeb, the chair of Harvard's astronomy department, proposed something controversial. What if Oumuamua wasn't entirely natural? What if it was a light sail, a piece of technology from another civilization? The scientific community went absolutely ballistic. Careers were threatened, reputations were questioned. But Loeb stood firm, saying something profound. The question of whether we are alone in the universe is one of the most fundamental questions in science. If we're not even willing to consider all possibilities when we see anomalous data, then we're not doing science anymore. We're doing religion. That was in 2017. Now flash forward to 2025, and we're watching 3I Atlas do things that make Oumuamua look perfectly normal by comparison. And this time, we have better telescopes, better data, and a much longer observation window. This time, we can't just dismiss the anomalies. So what exactly is 3I Atlas doing that's so disturbing? Let's talk about trajectories, because this is where the first major red flag appears. And once you see it, you can't unsee it. Every object in our solar system follows predictable paths determined by gravity. We can calculate these orbits with extraordinary precision. In fact, we're so good at orbital mechanics that we can predict where Jupiter will be 1,000 years from now within a margin of just a few kilometers. Gravity is reliable. Gravity is constant. Gravity is the ultimate cosmic accountant, and the books always balance. Except when they don't. On April 17, 2025, Dr. Michelle Bannister at the University of Canterbury in New Zealand published preliminary findings that sent shockwaves through the astronomical community. She'd been tracking 3I Atlas for 6 weeks, and the math wasn't working. The comet's trajectory was showing micro-adjustments that couldn't be explained by gravitational influences from known bodies. These weren't random fluctuations. They were corrections, course adjustments, as if something was steering. Now, before you jump to conclusions, let me explain what we're really seeing here. Natural comets can change their trajectories through a process called outgassing. As a comet gets closer to the sun, the ice on its surface sublimates directly from solid to gas, creating jets that can act like tiny rocket engines. This is called the rocket effect, and it's well documented. We've seen it hundreds of times. But here's what makes 3I Atlas different: the magnitude and timing of these adjustments. Think of it like this. Imagine you're driving a car, and every time you need to make a turn, you do it with millimeter precision at exactly the right moment to maintain perfect speed and direction. That's impressive driving. Now imagine the car is doing it by itself, and instead of a GPS, it's using frozen water evaporating randomly from its surface. Still buying it? The statistical analysis is what really raises eyebrows. Dr. Bannister's team calculated the probability of these course corrections happening naturally in the observed sequence. 1 in 847,000. Those aren't maybe it's just weird odds. Those are we need to seriously reconsider our assumptions odds. But wait, there's more, and this is where it gets truly mind-bending. On May 2, 2025, the Hubble Space Telescope captured something that shouldn't be possible. During one of its observation windows, 3I Atlas appeared to change its rotation rate. Not gradually, as you'd expect from outgassing or collisions with space debris, but suddenly. In less than 4 hours, its rotational period decreased from 23.7 hours to 19.3 hours. Here's why that's absolutely insane. Changing the rotation of an object in space requires torque, a twisting force. For a comet estimated to be between 2 and 4 kilometers in diameter, with a mass of approximately 10 trillion kilograms, the amount of energy required to alter its spin that quickly is enormous. We're talking about energy equivalent to multiple nuclear explosions. And it happened with no visible debris, no fragmentation, no evidence of an impact or internal explosion. What natural process could do that? Astronomers are scrambling for explanations. Maybe it's an unusual distribution of ice causing asymmetric outgassing? Maybe there's a pocket of extremely volatile materials that suddenly vaporized? Maybe we're just missing something obvious? But here's what keeps me up at night. Maybe we're asking the wrong questions entirely. Hold on, because what I'm about to tell you next makes everything we've discussed so far seem almost reasonable by comparison. Remember how I said 3I Atlas is doing this behind the sun? There's a reason that location matters more than you think. And when you understand why, your entire perspective on this situation is going to shift. But first, we need to talk about what happened when scientists tried to figure out where this thing actually came from. Tracing the origin of an interstellar object is like being a cosmic detective working a cold case that's millions of years old. You take the current trajectory, factor in the gravitational influences of every object it passed on its way in, and then run the math backwards through time. It sounds straightforward, but the computational requirements are staggering. You're essentially trying to rewind the universe while accounting for every gravitational interaction along a path that stretches across light years. Dr. Feng at the Carnegie Institution for Science led the team that attempted this backtracking for 3I Atlas. What they found was disturbing in its precision. When you run the calculations backward, 3I Atlas's trajectory points to a specific region of space, approximately 137 light-years away, in the direction of the constellation Ophiuchus. That's interesting, but not necessarily meaningful. Space is big, and pointing toward a constellation is like saying, somewhere over there. But here's where it gets specific and weird. Within that region, there's a system called Barnard's star, a red dwarf that's been of particular interest to astronomers for decades. In 2018, researchers announced the possible detection of a super-Earth planet orbiting in its habitable zone, though that finding remains controversial. What's not controversial is that Barnard's star is one of the closest stellar systems to Earth, just 6 light-years away from our Sun. Now, if 3I Atlas originated from that region 137 light-years away and traveled to Barnard's star's current position, then continued on to us, the timeline works out to something absolutely chilling. The object would have been launched from its origin point approximately 3.8 million years ago. Does that number mean anything to you? Because it should. 3.8 million years ago, something significant was happening on Earth. Our hominin ancestors were just beginning to walk upright. The genus Australopithecus was spreading across Africa. The very first primitive stone tools were being created. In cosmic terms, we were babies taking our first steps toward consciousness, toward civilization, toward becoming a species that could look up at the stars and wonder what's out there. And according to the trajectory data, that's precisely when something in the direction of Ophiuchus launched an object on a path that would take it past Barnard's star and directly toward our Sun. Coincidence? Maybe. Probably. Almost certainly. But here's what Dr. Feng said in a private correspondence that was later leaked to the broader scientific community. The precision required to launch an object on a trajectory that would bring it to our solar system 3.8 million years later, accounting for stellar drift and gravitational perturbations from countless intervening objects, would require computational capabilities far beyond anything we can currently imagine. If this trajectory was intentional, whatever sent it had to model the future positions of hundreds of stars with impossible accuracy. Think of it like this. Imagine standing in New York City and throwing a tennis ball with the intention of having it land in a specific person's hand in Tokyo, exactly 3 months from now, accounting for wind, weather patterns, the Earth's rotation, the person's movements, and 1,000 other variables. That's the level of precision we're talking about, except stretched across millions of years and trillions of kilometers. But let's play devil's advocate for a moment, because good science demands skepticism. Maybe 3I Atlas didn't come from that far away. Maybe our trajectory calculations are wrong. Maybe the gravitational influences we're accounting for are incomplete, and the actual origin point is much closer or much farther. Maybe it's just a coincidental alignment that our pattern-seeking brains are turning into a narrative. Except the data keeps getting weirder. On May 15, 2025, the James Webb Space Telescope turned its powerful infrared sensors toward 3I Atlas for a detailed spectroscopic analysis. What they found in its composition stopped the research team cold. Every comet we've studied has a predictable chemical signature. Water ice, frozen carbon dioxide, methane, ammonia, and various organic compounds in ratios that vary but stay within expected parameters. These ingredients are the leftovers from the formation of planetary systems, cosmic soup frozen in time. 3I Atlas has all of those things. But it also has something else, an unusually high concentration of technetium-99, a radioactive isotope that doesn't occur naturally in significant quantities because its half-life is only 211,000 years. In cosmic terms, that's the blink of an eye. Any technetium-99 that existed in the primordial solar system would have decayed away billions of years ago. So where did it come from? Technetium-99 is primarily produced in nuclear reactors and as a byproduct of uranium fission. On Earth, we use it in medical imaging. It's artificial. It's technological. And it's present in 3I Atlas in concentrations 400 times higher than any natural process should produce. Dr. Clara Martinez Vasquez at the Cerro Tololo Inter-American Observatory, who led the spectroscopic analysis, was very careful in her public statements. We're seeing an anomalous signature that requires further investigation. There may be undiscovered natural processes at play, but in private communications with colleagues, her language was different. I don't know how to explain this without invoking scenarios that would get me laughed out of every conference for the next decade. If you're feeling a creeping sense of unease right now, good. That means you're paying attention. Because we haven't even gotten to the truly disturbing part yet. What I'm about to reveal next involves the location where all of this is happening, why being behind the sun matters so much, and the one piece of data that made multiple scientists independently contact NASA with the same terrifying question. But to understand that, we need to talk about Lagrange points and the places in our solar system where the laws of physics create perfect hiding spots. Let me ask you something. If you wanted to observe Earth without being detected, where would you position yourself in the solar system? Your first instinct might be to say, far away, maybe out past Pluto where nobody's looking. But that's actually the worst choice, because distance makes observation difficult, and Earth-based telescopes would easily spot you against the mostly empty background of space. No, if you were smart, you'd hide in plain sight in one of the solar system's natural blind spots. And those blind spots exist because of something called Lagrange points. In 1772, Italian-French mathematician Joseph Louis Lagrange solved a complex problem in orbital mechanics. If you have two massive objects orbiting each other, like the Sun and Earth, are there any positions where a third, much smaller object could maintain a stable position relative to the two larger ones? The answer is yes. There are exactly 5 such points, now called Lagrange points, where gravitational forces and orbital motion balance perfectly. 3 of these points, L1, L2, and L3, sit in a line with the Sun and Earth. L1 is between them, L2 is beyond Earth, looking away from the Sun, and L3 is on the opposite side of the Sun from Earth. The other 2, L4 and L5, form equilateral triangles with the Sun and Earth, sitting 60 degrees ahead and behind Earth in its orbit. Now here's why this matters. We use Lagrange points all the time for satellites. The James Webb Space Telescope sits at L2, where it can observe deep space without interference from Earth's heat. The Soho Solar Observatory sits at L1, constantly watching the Sun. These are gravitationally stable parking spots that require minimal fuel to maintain position. But L3, the point directly opposite Earth on the other side of the Sun, has always been the mysterious one. We can't see it directly. The Sun is always in the way. For most of human history, we couldn't even confirm there was nothing there. It's the perfect blind spot, and every science fiction writer who ever wrote about a counter-Earth hidden from view, placed it at L3. On May 23, 2025, Dr. Robert McGregor at the LIGO Gravitational Wave Observatory noticed something unusual in the data. LIGO is designed to detect ripples in spacetime caused by massive cosmic events like colliding black holes. But it's sensitive enough to pick up smaller disturbances. And in the direction of solar L3, there were periodic fluctuations that shouldn't exist. The patterns were subtle, barely above the noise threshold, but they were regular. Every 47.3 hours, a small gravitational anomaly appeared in the data, lasting approximately 14 minutes before fading. This had been happening for months, but it was only when McGregor applied a new filtering algorithm that the pattern became visible. Here's what makes this significant. 3I Atlas's current trajectory is taking it directly through the L3 region, and the timing of these gravitational fluctuations corresponds almost exactly to when the comet should be at perihelion, its closest approach to the Sun, which happens to occur while it's behind the Sun from our perspective. Think of it like this. Imagine you're trying to have a secret meeting with someone, but there are security cameras everywhere. So you choose to meet in the one spot where the cameras can't see, during the exact window of time when the guards are changing shifts. The timing is too perfect. The location is too convenient. It screams intentionality. But I can hear you thinking, couldn't this just be a coincidence? Space is full of weird phenomena, and you're absolutely right to be skeptical. Science advances through skepticism. So let's look at what else is happening that makes the coincidence explanation increasingly difficult to maintain. On June 1, 2025, something unprecedented occurred. Multiple space weather monitoring stations detected a sudden, brief disruption in the solar wind, the stream of charged particles that constantly flows outward from the Sun. For approximately 8 minutes, the solar wind in a narrow cone pointing toward the L3 region decreased in intensity by 40%, as if something was blocking or absorbing it. Dr. Janet Green at NASA's Goddard Space Flight Center, who specializes in solar wind dynamics, had never seen anything like it. Solar wind can be disrupted by coronal mass ejections, by magnetic field reconfigurations, by various solar phenomena. But this was different. It was too localized, too brief, and too complete. It's as if someone opened an umbrella in a rainstorm for exactly 8 minutes, then closed it again. The data from multiple satellites confirm it. Something in the L3 region had interacted with the solar wind in a way that required either an enormous magnetic field or a physical barrier. 3I Atlas is not nearly large enough to produce such an effect through its coma, the cloud of gas and dust that surrounds a comet's nucleus. Even the most generous estimates of its size and outgassing rate fall short by orders of magnitude. So what are we looking at? Here are the possibilities, ranked from most to least conventional. 1. We're missing something fundamental about how comets interact with solar wind. Maybe exotic ice compositions can create temporary magnetic field anomalies we've never observed before. This is the "it's weird but natural" explanation. 2. 3I Atlas is not alone. Maybe there's a larger object or a cluster of objects at L3 that we haven't detected, and 3I Atlas is just a visible piece of something bigger. This is the "there's more out there we can't see" explanation. 3. 3I Atlas is not what it appears to be. Maybe it's not a comet at all, but something else masquerading as a comet, using outgassing as camouflage to hide its true nature. This is the anomalous object explanation. And 4. The explanation that makes careers end and scientific papers get rejected, the one that nobody wants to say out loud, but everyone is thinking. What if 3I Atlas is exactly what it looks like? A probe, a vessel, a piece of technology from somewhere else, rendezvousing with something at L3 that's been waiting there, watching us, hidden behind our sun for who knows how long. Your mind is probably racing right now, trying to reconcile what you think you know about reality with what the data seems to be suggesting. Good. Hold on to that feeling, because it's about to get exponentially stranger. What I'm going to show you next involves communication signals, mathematical patterns that can't occur naturally, and the question that every government space agency is asking behind closed doors if something is out there. And if 3i Atlas is connected to it, what happens when they finish whatever they're doing behind the sun and come around where we can see them? Let's talk about signals, because this is where we cross from highly anomalous natural phenomena into territory that makes even the most open-minded scientists uncomfortable. And before I go further, I want to emphasize something. What I'm about to share with you is based on verified data from multiple sources, but the interpretations are controversial, heavily disputed, and career-threatening for anyone who takes them seriously in public. That's not me being dramatic. That's just the reality of modern astronomy when you start suggesting that something artificial might be happening in our cosmic backyard. On June 8, 2025, Dr. Sophia Cheung at the Breakthrough Listen project detected something that changed everything. Breakthrough Listen is a $100 million initiative to search for evidence of intelligent life in the universe by monitoring radio frequencies from space. They're looking for signals that don't match natural sources, patterns that suggest intentional transmission, technosignatures that could only come from technology. Most of the time, they find nothing. Or more accurately, they find plenty of interesting signals that turn out to be pulsars, quasars, solar bursts, or interference from Earth-based sources. The universe is noisy, and natural processes can create patterns that look deceptively artificial. Distinguishing true technosignatures from natural phenomena is one of the hardest challenges in radio astronomy. But at 3:47 UTC on June 8th, the Parkes Radio Telescope in Australia, operating as part of the Breakthrough Listen network, detected a narrow-band signal at 1.42 GHz, the frequency of neutral hydrogen's emission line. This frequency is significant because it's considered a universal hailing frequency. If aliens wanted to get our attention, they'd broadcast at a frequency that any civilization doing radio astronomy would naturally be monitoring. The signal lasted for 67 seconds. It originated from the direction of solar L3, and its structure was unmistakable, a repeating pattern of prime numbers. Let me explain why that's significant. Prime numbers, integers greater than 1, that can only be divided by 1 and themselves, don't appear in nature as signals. Natural processes can create regular patterns. Pulsars emit radio waves at precise intervals, determined by their rotation. Quasars have characteristic spectra determined by their composition. But broadcasting a sequence of prime numbers requires intentionality. It requires mathematics. It requires intelligence. The sequence detected by Breakthrough Listen went 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, repeating 3 times before stopping. Each number was represented by that many pulses of the carrier signal, with clear gaps between numbers. There's no ambiguity in the data. This wasn't a random pattern that humans interpreted as primes. This was a deliberate mathematical message. Dr. Cheung's team immediately initiated their protocol for verifying potential technosignatures. They checked for interference from satellites, ground-based transmitters, and known cosmic sources. They had other telescopes attempt to confirm the signal. They analyzed the Doppler shift to rule out Earth-based origin. Every verification step came back, confirming the same thing. This signal originated from outside Earth, from the direction of solar L3, and it contained information that could only be artificial. Here's where it gets even more disturbing. 37 minutes after that first signal, a second transmission was detected, this time by the FAST telescope in China. Same frequency, same source direction, but a different message. This time, instead of prime numbers, the signal contained a binary sequence that, when converted to decimal, produced the number 12.37. That number meant nothing to the astronomers at first. But then someone on the team realized 1237. Astronomical units is the approximate average distance from the Sun to 3i Atlas based on its orbital calculations. The signal was broadcasting a distance. It was saying, "We are here." Think about what this means. If this is real, and that's a massive if that I want to emphasize, then we're not just detecting anomalous behavior from an interstellar object. We're detecting intentional communication associated with that object. We're watching something that's actively trying to tell us something about its position relative to our sun. But here's what really keeps me awake at night. Those signals weren't directed at Earth. The narrowband transmission was pointed perpendicular to the Sun-Earth line toward empty space. We only detected them because radio waves spread out as they travel, and we happened to be in the outer edge of the beam. These weren't messages to us. They were messages to, or from something else. Dr. Martin Rees, the former Astronomer Royal of the United Kingdom and one of the most respected voices in astrophysics, made a rare public comment about these detections. If these signals are confirmed and proven to be artificial in origin, we must consider the possibility that we are witnessing communication between components of a much larger system. The implications for our understanding of intelligent life in the universe would be profound and unsettling. Now, let's ground ourselves in skepticism for a moment, because this is where conspiracy theories thrive and scientific rigor dies. Radio interference is everywhere. The likelihood of false positives in SETI research is extraordinarily high. There are countless ways that natural phenomena, human technology, and data processing artifacts can create patterns that look artificial. The history of astronomy is littered with discoveries that turned out to be nothing. The famous "wow" signal detected in 1977 was never repeated. The pulsing signals from LGM-1, initially thought to be alien transmissions, turned out to be the first pulsar. Every few years, someone claims to have found a technosignature, and every time, further investigation reveals a mundane explanation. Science demands extraordinary evidence for extraordinary claims, and a couple of ambiguous radio signals, no matter how intriguing, don't meet that threshold. But here's what's different this time. We have corroborating data from multiple, independent observation methods. We have the gravitational anomalies detected by LIGO. We have the trajectory corrections documented by optical telescopes. We have the compositional oddities found in spectroscopic analysis. We have the solar wind disruption recorded by space weather satellites. And now we have radio signals that correspond temporally and directionally with all of these other anomalies. In isolation, each piece of data is interesting but explainable. Together, they form a pattern that's increasingly difficult to dismiss as coincidence. So let's address the elephant in the room, the question that everyone's thinking but afraid to ask. If 3I Atlas is artificial, if there's something at L3, if this is all real and not just a series of extraordinary coincidences, then what is it? What could explain all of these observations? What are we actually looking at? This is where science meets speculation, where data meets interpretation, and where I need to be very clear about the difference between what we know and what we're hypothesizing. What I'm about to present are working models that various research teams are exploring, not proven theories. Think of them as frameworks for understanding the data, not definitive answers. Model 1. The Berserker Probe Hypothesis. This is the darkest interpretation, named after the self-replicating destructive probes in Fred Saberhagen's science fiction stories. The hypothesis suggests that 3I Atlas could be an autonomous probe designed to travel between star systems, seeking out planetary systems with certain characteristics. Once it arrives, it could perform various functions: observation, resource extraction, or in the worst-case scenarios, planetary sterilization to prevent competition. The evidence that fits this model: the trajectory precision suggesting intentional navigation, the chemical composition indicating technological origin, the apparent rendezvous with something at L3, the communication signals. All of these are consistent with an autonomous probe designed for interstellar travel. The problems with this model: there's no evidence of hostile action. 3I Atlas isn't doing anything threatening. It's not approaching Earth, not showing weapon signatures, not exhibiting any behavior that suggests danger. If this is a probe, it seems to be purely observational, which leads us to the next model. Model 2, the exploration vessel hypothesis. This interpretation suggests that 3I Atlas is part of an exploratory mission, similar in concept to our own Voyager probes or New Horizons spacecraft, but on a vastly larger scale and from a much more advanced civilization. The object at L3 could be a mothership or a long-duration observation station, and 3I Atlas could be a scout reporting back. Think of it like this. Imagine if humanity sent a probe to Alpha Centauri that could release smaller scouts to investigate individual planets in that system. The scouts would report data back to the main vessel, which would compile information for eventual transmission back to Earth. This is functionally what we're observing, just in reverse. We're the system being explored. The evidence supporting this. The communication signals suggest data transmission. The position at L3 makes sense for long-term, undetected observation of Earth. The timing of the arrival, coinciding with humanity's emergence as a technological species, could indicate triggered exploration. Civilizations might have automated systems that investigate planets once they show signs of radio emissions or other technosignatures. The challenge with this model, it requires technology and resources far beyond anything we can currently imagine. Sending an interstellar probe that can function for millions of years, that can position itself precisely at a Lagrange point, that can dispatch scouts and maintain communication. This implies a level of technological sophistication that makes our entire space program look like children playing with wooden toys. Model 3, the panspermia arc hypothesis. This is the most biologically oriented interpretation. What if 3I Atlas isn't a probe in the conventional sense, but a delivery system for life itself? Panspermia is the theory that life exists throughout the universe and spreads between planetary systems via comets, asteroids, or intentional seeding by advanced civilizations. Some versions of this theory suggest that civilizations facing extinction might send out biological material to seed other worlds, ensuring that life continues even if they don't. Others propose that advanced civilizations might deliberately spread life as an act of cosmic gardening, preparing worlds for eventual habitability. The evidence, the high concentration of organic compounds in 3I Atlas's composition, the precise timing of its arrival relative to Earth's biological development, the positioning at L3, which could be optimal for releasing biological material that would eventually make its way to Earth via solar wind and orbital dynamics. The counter-argument: we have no evidence of biological material being released. No unexplained meteor showers, no anomalous atmospheric entries, no new organisms appearing mysteriously. If this is a seeding mission, it hasn't done any seeding yet? Model 4, the archaeological survey hypothesis. This interpretation is more philosophical than the others. What if 3I Atlas is part of an archaeological mission, not from space, but from time? What if this is a probe from Earth's own distant future, sent back through time, or through some form of faster-than-light travel that we don't yet understand, to observe and document humanity's emergence? I know, this sounds like science fiction. But hear me out. If we assume that time travel, or FTL travel, becomes possible at some point in humanity's future, then it's logical that future civilizations would want to observe their own past. The precise timing, the careful positioning, the apparent interest in Earth specifically, all of these make more sense if the observers are us from the future rather than aliens from elsewhere. The problem: this requires physics that we have no evidence for. Time travel remains purely theoretical, with enormous logical and causal problems. FTL travel appears to violate fundamental laws of physics. This model requires the most speculative science, which makes it the least likely despite its narrative appeal. Dr. Kevin Hand at NASA's Jet Propulsion Laboratory, who studies the potential for life in extreme environments, offered this perspective. When we encounter truly anomalous data that doesn't fit our existing models, we have two choices. We can expand our models to accommodate the data, or we can reject the data as flawed. But we must be careful not to let our comfort with existing paradigms blind us to genuine novelty. The universe is under no obligation to make sense to us. I want you to stop for a moment and really consider what we've discussed so far. We've moved from basic comet mechanics to signal detection to hypothetical models of artificial intelligence spreading through the cosmos. And we're only approaching the midpoint of this journey, because everything I've shared with you so far has been about the object, the data, the external phenomena. But what I'm about to explore next is more important than any of that. What this means for you, for humanity, for our understanding of our place in the universe. And why, regardless of whether 3I Atlas is natural or artificial, its existence is going to fundamentally change how we see ourselves. Let me ask you something personal. Have you ever looked up at the night sky and felt both insignificant and special at the same time? That paradoxical feeling where you're aware of how tiny you are compared to the cosmos, but also aware that you're part of something vast and meaningful? That feeling is about to get a lot more complicated, and here's why. For all of human history, we've been fundamentally alone. Yes, we've had each other. We've built civilizations. We've created art and science and philosophy. But in cosmic terms, we've been shouting into a void with no expectation of an answer. The universe has been a stage where we're the only actors, playing out our dramas to an audience of silent stars. 3I Atlas, regardless of what it actually is, has changed that equation. For the first time in human history, we have data, real, verifiable, scientific data that suggests we might not be alone. Not in a vague, the universe is big, so probably there's something out there way, but in a, there is an anomalous object doing strange things in our solar system right now way. Think about what this means for your daily life. Every morning when you wake up, every time you look at the sky, every moment you spend going about your routine, all of this is happening while something potentially extraordinary unfolds behind our sun. It's like finding out that while you've been living your life, assuming you understood the basic rules of reality, there's been something else happening just out of sight that changes everything. But here's what really blows my mind about this situation. Whether 3I Atlas is natural or artificial almost doesn't matter anymore. The very fact that we're having this conversation, the credible scientists are seriously considering explanations that would have been dismissed as science fiction just a few years ago, means we've crossed a threshold. We've moved from "are we alone?" to "what do we do if we're not?" Dr. Jill Tarter, who spent decades leading SETI research, said something profound in a lecture at Stanford in 2023. The detection of extraterrestrial intelligence won't just be a scientific discovery. It will be an existential recalibration. Every human being will have to reconsider their place in the universe, their significance, their purpose. It will be the most democratizing moment in human history. Everyone, everywhere, will be equally affected. That moment might be happening right now, and you're watching it unfold in real time. But I want to dig deeper into what this means for you specifically, because the implications are far more personal than you might realize. Let's start with something fundamental, your sense of time. Right now, you probably think about time in human scales. Your childhood feels like ancient history. A decade is a long time. A century is incomprehensible. But 3I Atlas, if it was sent from somewhere 3.8 million years ago, is operating on timeframes that make human history look like a blink. All of recorded human civilization, Mesopotamia, Egypt, Greece, Rome, the Renaissance, the Industrial Revolution, the digital age, all of it has happened in the time it took this object to travel from wherever it came from to where it is now. Think of it like this. Imagine you planted a tree that would take 3.8 million years to grow, and you knew that when it finally reached maturity, it would produce a single fruit. That's the level of patience and long-term thinking we're potentially dealing with. Whatever sent 3I Atlas, if anything did, thinks in time frames that make geological epochs look hasty. What does that mean for you? It means that if there are other intelligences out there, they might not even perceive time the way we do. To them, human civilization might appear and disappear in what seems like seconds. Your entire life, everything you'll ever experience, might be a momentary flicker in their perception. That's simultaneously humbling and terrifying, but it's also strangely comforting. It means our struggles, our anxieties, our daily stresses are part of a much larger tapestry. Now let's talk about significance. One of the biggest existential questions humans face is, do we matter? Does anything we do have meaning in the grand scheme of things? And for most of human history, we've had to create our own answers to that question, because the universe wasn't providing any feedback. But if 3I Atlas is artificial, if something out there is watching us, then we matter to someone or something beyond ourselves. We're significant enough to be observed. We're interesting enough to merit attention. In a universe of trillions of stars and potentially billions of planets, something chose to point instruments in our direction. That's not necessarily comforting. Being watched isn't always pleasant, but it does answer a fundamental question about meaning. You matter because something else recognizes that you exist. Your species, your planet, your civilization, all of it is noteworthy enough to be studied. But here's the flip side that I think is even more important. Even if 3I Atlas is completely natural, even if every anomaly we've detected has a mundane explanation, the fact that we're capable of detecting it, analyzing it, and asking these questions proves something profound about humanity. We've gone from primitive hominids banging rocks together to a species that can detect trace elements in objects billions of miles away, that can calculate trajectories across millions of years, that can listen for signals from beyond the stars. You are part of the first generation of humans who can realistically ask, are we alone? And have a chance of getting an answer within your lifetime. Your grandparents didn't have that. Your great-grandparents couldn't even imagine it. But you, right now, in your lifetime, might witness the confirmation of other intelligent life. Or you might witness the confirmation that we're alone, which in its own way is just as profound. Dr. Lisa Kaltenegger, who directs the Carl Sagan Institute at Cornell, put it beautifully. Every human being alive today is living in the most important moment in human history, the moment when we transition from wondering if we're alone to knowing the answer. That's not hyperbole. That's not exaggeration. That's just the mathematical reality of where our technology and our curiosity have taken us. Let me make this even more personal. What are you afraid of? Not physical fears like heights or spiders, but existential fears. The fear that your life doesn't matter. The fear that consciousness is just an accident, a cosmic fluke with no deeper meaning. The fear that when you die, that's it. Everything you were, everything you experienced, just ends and is forgotten. 3I Atlas and everything it represents speaks to those fears. If we're being observed, if we're part of a larger cosmic story, then individual lives might be fleeting, but the pattern continues. You're a note in a symphony that spans galaxies and eons. Your specific note matters because without it, the symphony would be incomplete. Or to put it another way, you are the universe examining itself. You are the cosmos that has become conscious enough to look outward and ask questions. Every thought you have, every moment of wonder, every time you contemplate your place in existence, that's the universe experiencing itself through you. And if there are others out there also experiencing that same wonder, then we're all part of something vast and interconnected. But let's address the scarier side of this, because I promised you honesty. What if 3I Atlas represents something dangerous? What if the signals we're detecting aren't friendly greetings, but warning beacons? What if advanced civilizations seed the galaxy with probes specifically to identify emerging species and evaluate whether they're threats? This is called the dark forest hypothesis, based on Lou Sixson's science fiction trilogy. The idea is that the universe is like a dark forest full of armed hunters. Everyone is hiding because revealing your position might attract something hostile. Civilizations that broadcast their existence don't survive. And probes like 3i Atlas might be the tripwires that signal when a new civilization has reached technological maturity. I don't say this to frighten you, but because ignoring the possibility isn't scientific. If we're considering the implications of 3i Atlas, we have to consider all of them, not just the comforting ones. And here's what I find oddly reassuring about even the dark scenarios. They require that the universe is full of life, full of intelligence, full of civilizations making choices and mistakes and struggling with the same questions we are. Even the scary versions of contact mean we're not alone. So what should you do with this information? How should it change your life? Here's my answer. It should make you pay attention. Not just to 3i Atlas, not just to space news, but to everything. To the fact that you're alive during a pivotal moment in human history. To the reality that every person you meet is part of this same cosmic story. To the beauty of existing in a universe complex enough to produce consciousness that can wonder about itself. You should look at the sky differently. You should consider your actions more carefully, knowing that if we are being watched, how we treat each other, how we treat our planet, how we develop our technology, all of that is being observed and recorded. We're not just living for ourselves anymore. We're potentially representing humanity to something beyond humanity. And you should feel empowered. Because if we're capable of detecting something like 3i Atlas, of analyzing it, of asking these profound questions, then we're capable of so much more than we give ourselves credit for. The anxieties you have about your job, your relationships, your purpose, all of those are valid and real, but they're also part of a species that's reaching for the stars. You contain multitudes. We all do. Now, I need to tell you about what happened in late June 2025, because this is where the story takes a turn that nobody predicted. Remember those signals we detected? Remember the gravitational anomalies? Well, scientists decided to do something that was either incredibly brave or incredibly foolish, depending on who you ask. They decided to respond. And what came back changed everything we thought we knew about this situation. But to understand why their response was so controversial, we need to talk about something called the meaty problem, and why some of the smartest people on Earth think actively trying to contact aliens might be the biggest mistake our species could ever make. There's a fierce debate in the scientific community that's been raging for decades. Should we actively transmit messages into space, or should we just listen? It's called the METI versus SETI debate, messaging to extraterrestrial intelligence versus searching for extraterrestrial intelligence. And it gets heated in ways that academic debates rarely do, because the stakes are potentially existential. The argument against METI goes like this. We have no idea what's out there. Broadcasting our location to the cosmos is like walking into an unknown forest and shouting, "Here I am." You might attract friendly hikers. You might attract nothing. Or you might attract predators. Once you've announced yourself, you can't take it back. The message travels at the speed of light forever, expanding outward as an ever-growing sphere of revelation. Stephen Hawking was famously against METI. He argued that any civilization capable of detecting and responding to our signals would be technologically superior to us, and history shows that when a technologically advanced civilization encounters a less advanced one, things don't usually go well for the less advanced one. He said, if aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. The argument for METI is more optimistic. Maybe advanced civilizations are benevolent. Maybe they're waiting for us to demonstrate that we're capable of reaching out. Maybe the universe is full of civilizations that follow some kind of protocol. You don't contact a species until they contact you first. And besides, we've already been broadcasting radio and television signals for over a century. Earth has a bubble of electromagnetic radiation 200 light years across announcing our presence. The cat's out of the bag. Now, here's where 3i Atlas makes this debate extremely relevant. On June 23, 2025, a coalition of scientists from 7 countries made a decision that bypassed all normal protocols. They used the Arecibo Successor Telescope, the upgraded facility in Puerto Rico, to transmit a focused radio message directly toward the L3 region. The message was simple, a mathematical sequence similar to what had been received, followed by a binary representation of Earth's position in the solar system, followed by a count of humans on Earth, approximately 8.1 billion, followed by a simple question encoded in prime numbers that essentially asked, "What are you?" Dr. Rebecca Torres, who led the transmission team, defended the decision. "We are not revealing anything that isn't already obvious to any observers. If there's something at L3, it's been in our solar system for months, possibly much longer. It knows we're here. The only question is whether we acknowledge that we're aware of it." But Dr. Michael Jong at Oxford, one of the most vocal opponents of active METI, was furious. This is the most irresponsible action in the history of astronomy. We've unilaterally decided on behalf of our entire species to initiate contact with something we don't understand, based on data we haven't fully verified, without global consensus or any plan for what to do with the response. This is madness dressed up as science. The transmission was 30 minutes long, broadcast at 1.42 gigahertz, aimed at where calculations predicted L3 would be accounting for the sun's rotation and movement. And then everyone waited. Radio waves travel at the speed of light. The distance to L3 is approximately 2 astronomical units, which means light and radio waves take about 16 minutes to make the journey. Round-trip communication time would be 32 minutes, assuming an instant response. At exactly 32 minutes and 47 seconds after the transmission, the Parkes telescope in Australia detected a response. Let me repeat that. They got a response. Not after days of waiting, not after weeks of analysis. 32 minutes and 47 seconds. The 47-second discrepancy corresponds almost exactly to the processing time you'd expect for decoding the message, formulating a response, and transmitting it back. The response was longer than the original message. Much longer. It lasted for 3 hours and 17 minutes. And when the data was processed, what it contained made every person in the analysis room stop breathing. The message started with the same mathematical sequence we'd sent, confirming it had received and understood our transmission. Then it sent back Earth's position, not just in the solar system, but in the galaxy, with a precision we couldn't match with our best stellar cartography. Then it sent a number, 8,127,432,991. That's the human population of Earth, as of June 23, 2025, at the exact moment of transmission, accurate to within estimated statistical margins. Think about what that means. Whatever sent this message knows how many humans are on Earth right now. Not an estimate, not a rough calculation, an accurate count. That requires observation capabilities far beyond anything we possess. That requires monitoring us in real time with resolution sufficient to track individual humans. But here's where it gets truly mind-bending. The message then sent a second number, 16. Just 16. No context, no explanation. Dr. Torres's team spent hours trying to decode the significance of 16. 16 what? 16 objects? 16 messages? 16 years? 16 light years? The number seemed arbitrary until someone suggested, what if it's not a quantity? What if it's a percentage? If 16 represents 16%, then the question becomes, 16% of what? And that's when Dr. Helena Costas, A linguistics expert who'd been brought in to help with the analysis suggested something that made everyone's blood run cold. What if it means 16% of observed civilizations survive contact? The room went silent. Because if that interpretation is correct, then the message isn't just a friendly acknowledgement. It's a warning. It's saying, we see you, we count you. And by the way, most species that reach this point don't make it past the next stage. But interpretations are tricky, especially when you're dealing with communication from something completely alien. Maybe 16 means something entirely different. Maybe it's the number of probes in our system. Maybe it's a time frame, 16 days, 16 months, 16 years until something happens. Maybe it's completely benign data about their own civilization. Dr. Douglas Vekic, who spent decades designing messages for potential alien recipients, cautioned against overinterpretation. We're pattern-seeking creatures. We see meaning everywhere, especially when we're anxious and dealing with incomplete information. This number could mean anything or nothing. We're projecting our fears onto ambiguous data. The message didn't end with a number. The final portion of the transmission was the most complex. It contained what appeared to be a star map, similar to the one we included on the Voyager Golden Record in 1977. But this map was vastly more detailed, showing hundreds of stars with some marked in a way that suggested special significance. When the cartography team analyzed the map, they found something disturbing. 14 of the marked stars correspond to systems where SETI has detected candidate technosignatures over the past 50 years. Signals that were interesting but never confirmed. Anomalies that were noted but never followed up on. Systems where we detected something unusual but couldn't verify it. All 14 of those systems are silent now. Not just quiet, completely silent across all frequencies we've monitored. It's as if whatever was there simply stopped transmitting, or stopped existing. Dr. Jian Chun at the Chinese Academy of Sciences, who led the analysis of the star map, was careful in his conclusions. We're seeing a correlation between the marked stars in the message and systems where we previously detected anomalies. This could indicate that whatever sent this message is aware of other technological civilizations. Whether those civilizations are still active, we cannot determine from the available data. But in private conversations, Sean was less diplomatic. They're showing us a graveyard. Every one of those marked stars corresponds to a civilization that emerged, broadcast its presence, and then went silent. And now they're showing us this map and asking us what we want to do. They're giving us a choice: stay quiet and maybe survive, or continue broadcasting and join the others in silence. So now we need to talk about what this response means for the bigger picture, because the implications extend far beyond just 3i Atlas and whatever's at L3. This is about the Fermi paradox. The great filter and the question of why, in a universe that should be teeming with intelligent life, we seem to be alone. The Fermi paradox is named after physicist Enrico Fermi, who famously asked during a lunch conversation in 1950, "Where is everybody?" The paradox is this: the universe is about 13.8 billion years old. There are at least 100 billion galaxies, each containing hundreds of billions of stars. Even if only a tiny fraction of those stars have planets, and only a tiny fraction of those planets develop life, and only a tiny fraction of those develop intelligent life, there should still be millions of civilizations out there. Many of them should be far older and more advanced than us. So where are they? Why haven't we detected them? Why haven't they colonized the galaxy? Why isn't the sky full of their signals, their megastructures, their probes? There are dozens of proposed solutions to the Fermi paradox, but they generally fall into a few categories. First, we're alone. Life is incredibly rare. Intelligence is even rarer. And technological civilization is so improbable that we might be the only one in the observable universe. This is called the rare Earth hypothesis. Second, They're out there, but we can't detect them yet. Maybe they're communicating in ways we haven't thought of. Maybe they're so advanced that their technology looks like natural phenomena to us. Maybe they're deliberately hiding. This is the zoo hypothesis, or the dark forest scenario we discussed earlier. Third, civilizations don't last. Something happens that prevents them from surviving long enough to become detectable. This is called the Great Filter, some obstacle in the development of civilizations that almost none of them overcome. The Great Filter is the scariest solution because it has two possibilities. Either the filter is behind us, meaning the hard step was the origin of life or the evolution of intelligence, and we've already overcome the hardest part, or the filter is ahead of us. And if it's ahead of us, then we're facing some challenge that destroys virtually every civilization that reaches our level of development. What could that challenge be? Nuclear war, engineered pandemics, artificial intelligence that turns hostile, environmental collapse, nanotechnology gray goo. There are dozens of ways a civilization could destroy itself once it reaches a certain level of technological capability. But here's what the 3I Atlas situation suggests. What if the Great Filter isn't self-destruction? What if it's detection? What if the universe is full of predator civilizations, or enforcement mechanisms, or even well-meaning but ruthless galactic gardeners who call emerging civilizations that show dangerous characteristics? Dr. Robin Hanson, an economist who coined the term Great Filter, has been following the 3I Atlas developments closely. In a recent blog post, he wrote, "If the star map received in the June 23rd transmission is authentic and accurately depicts the fates of detected civilizations, then we may have just discovered the nature of the Great Filter. It's not that civilizations destroy themselves. It's that they're destroyed by something else once they become detectable. The silence we observe isn't the silence of absence. It's the silence of extinction. That's absolutely terrifying. It suggests that broadcasting our presence, reaching out, trying to make contact, all of the things we've done with SETI, all of the radio and television signals we've leaked into space, might have marked us for something terrible. But wait. Before you spiral into existential dread, let's consider alternative interpretations, because jumping to the worst conclusion isn't scientific. What if the star map isn't showing destroyed civilizations, but rather graduated ones? What if those silent systems went quiet because they moved beyond radio communication, beyond physical existence as we understand it, beyond anything we can currently detect? Dr. Paul Davies, a physicist and astrobiologist, suggests, we assume that advanced civilizations continue to broadcast radio signals forever, but that's probably wrong. We've only been using radio for about 130 years. Already, we're moving toward more efficient, more targeted communication methods. A civilization 1,000 years ahead of us might communicate in ways that are completely invisible to our current technology. Silence doesn't necessarily mean death. It might mean graduation to a higher level of existence. That's a more hopeful interpretation. The marked stars aren't graveyards. They're graduation points. The civilizations that were there achieved something that allowed them to transcend our ability to detect them. And maybe 3I Atlas is showing us that map not as a warning, but as an invitation. Here are the civilizations that made it. You can join them if you figure out how. There's another possibility that I think deserves consideration. What if the entity behind 3I Atlas is testing us? What if this entire scenario, the anomalous behavior, the signals, the star map, the ambiguous message, is designed to see how we respond when faced with uncertainty and potential danger? Think about it from the perspective of an advanced civilization that wants to evaluate whether a newly detected species is worth contacting. You can't just show up and say hello, because you don't know if they're peaceful, technologically ready, psychologically prepared, or ethically developed enough for full contact. So you create a scenario that reveals their character through their response. Do they react with fear and aggression? Do they respond with curiosity and caution? Do they come together as a species? Or do they fragment into competing factions? Do they thoughtfully consider the implications? Or do they make hasty decisions based on emotion? The response to 3I Atlas so far has been mixed. Some countries are cooperating, sharing data, coordinating observation schedules. Others are pursuing independent investigations, keeping information classified. Some scientists are advocating for continued communication attempts. Others are calling for radio silence. There are proposals for planetary defense preparations. There are proposals for welcoming committees. We're revealing ourselves through how we handle this situation. And if this is a test, then the grade we're getting isn't great. We're showing ourselves to be a species that's technologically capable, but politically fractured, scientifically curious, but prone to speculation, capable of cooperation, but also capable of panic and secrecy. Dr. Catherine Denning, an anthropologist who studies the cultural implications of contact scenarios, offered this insight. First contact, if it happens, won't just be between humans and aliens. It'll be between different versions of humanity, different cultures, different nations, different value systems, all trying to present a unified front while simultaneously pursuing their own interests. The aliens, if they're watching, are getting a front row seat to human nature in all its complexity. Now here's something that should give you hope. Despite all the fear, despite all the uncertainty, despite the potential dangers, humans haven't backed down. We haven't stopped observing. We haven't stopped analyzing. We haven't stopped asking questions. That resilience, that curiosity, even in the face of the unknown, might be our most valuable characteristic. We're about to enter the final stretch of this journey, and what comes next is going to challenge everything we've discussed so far. Because in mid-July 2025, something changed. 3I Atlas began its journey around the sun, emerging from behind where we could observe it directly. And what we saw when it came into view was nothing like what we expected. The data we collected in those weeks has forced scientists to reconsider not just this particular object, but our entire understanding of what's possible in our solar system. But before I show you what we found, we need to talk about what happens when 230 years of astronomical certainty meets something that shouldn't exist. On July 14, 2025, 3I Atlas completed its perihelion passage and began emerging from behind the sun. For the first time in months, telescopes had a direct line of sight without solar interference. Every major observatory on Earth and in space was pointed at its projected coordinates. The anticipation in the astronomical community was electric. Whatever this thing actually was, they were finally going to see it clearly. What they saw defied every prediction. First, the size was wrong. Comet nuclei typically range from a few hundred meters to perhaps 40 kilometers across. Based on its brightness and the calculations of its orbit, 3I Atlas should have been about 3 to 4 kilometers in diameter. But when the highest resolution images came back from the Hubble Space Telescope and the James Webb Space Telescope working in concert, the object measured approximately 47 kilometers at its longest axis. That's not just bigger than expected. That's an order of magnitude off. And here's what makes it even stranger. An object that size, with that much surface area, should have a coma, the cloud of gas and dust, that's vastly larger and brighter than what was being observed. It was as if the object was suppressing its outgassing, preventing it from creating the typical comet appearance. Dr. Naomi Rowe Gurney at NASA Goddard, who analyzed the initial images, said what everyone was thinking. This doesn't behave like any comet we've observed. The surface albedo, the reflectivity, is wrong. Comet nuclei are among the darkest objects in the solar system, typically reflecting only 3 to 5% of incident light. This object reflects nearly 40%. That's closer to ice or metal than dirty ice. But the real shock came when they analyzed the shape. Comet nuclei are regular, lumpy, potato-shaped objects formed by gravitational collapse and countless collisions. They're natural, chaotic, random in their geometry. 3I Atlas was none of those things. The object was cylindrical, almost perfectly so, with a length-to-width ratio of approximately 7:1. The ends were rounded but symmetrical. The surface showed what appeared to be regular patterns, geometric arrangements that couldn't be dismissed as pareidolia, the human tendency to see patterns in randomness. These were actual structures, repeating every 4.7 kilometers along its length. Think about what it means to see geometric regularity on a celestial object. We've seen geometric patterns before: the hexagon on Saturn's North Pole, the linear features on Jupiter's moon Europa. But those have clear natural explanations: atmospheric dynamics for Saturn, tectonic stress for Europa. What natural process creates a 47-kilometer cylinder with regular surface features? Dr. Sean Raymond, an astrophysicist who specializes in planetary formation, was blunt in his assessment. I can't think of any accretion process, any collision scenario, any natural formation mechanism that would produce this shape. Asteroids can be elongated due to rubble pile structures or tidal forces. But this isn't elongated. It's cylindrical. It's manufactured. That word, manufactured, appeared in multiple scientific papers published in late July 2025. Scientists who had been extremely careful to avoid any suggestion of artificiality were now openly discussing the possibility that 3I Atlas was not a natural object. But it gets weirder. Remember those rotation changes we detected earlier, the ones that shouldn't be possible? When 3I Atlas came into full view, observers noticed something that explained those changes, but the explanation was somehow more disturbing than the mystery. The object was rotating, but not around a single axis. It was exhibiting what's called complex rotation, or tumbling, rotating around multiple axes simultaneously. But here's the thing: the tumbling wasn't chaotic. It was controlled, precise, repeating in exactly 19.3-hour cycles that matched perfectly with the rotation rate we'd measured during its time behind the sun. Dr. Timothy Swindle at the University of Arizona, who has spent decades studying asteroid rotation, explained, complex rotation usually occurs after a collision that imparts angular momentum in multiple directions. But those rotations are unstable. They change over time due to internal stress and tidal forces. This rotation is perfectly stable, perfectly repeating. That requires either an impossible internal structure or active stabilization. Active stabilization. That phrase appeared more and more in the technical literature, the implication being that something aboard or within 3I Atlas was controlling its rotation, maintaining it in a specific configuration for a specific purpose. What purpose? The best guess came from analyzing what the cylinder's orientation revealed at different points in its rotation. At certain angles, specific surface features would become visible or illuminated by the sun. And when researchers mapped out which features were visible when, they found something extraordinary. The rotation was timed such that the same surface features would face Earth at regular intervals. It was showing us something, deliberately presenting specific parts of its surface for observation. On July 28, 2025, during one of these optimal viewing windows, the Atacama Large Millimeter Array in Chile captured the highest resolution surface scan ever achieved of 3I Atlas. And what they found, engraved into the surface, in patterns too regular to be natural, were mathematical constants. Pi, to 47 decimal places, represented as a spiral pattern of raised and depressed areas. The golden ratio, similarly encoded. The fine structure constant of quantum electrodynamics. Planck's constant. These weren't random features being misinterpreted. These were deliberate inscriptions of fundamental mathematical and physical constants, written in a universal language that any technological civilization would understand. Dr. Sharmila Bhattacharya at Berkeley, who verified the patterns, said, "This is a message. This is unmistakable communication. Whatever created this object wanted to be absolutely clear that it's artificial. They're showing us mathematics because mathematics is universal. They're essentially saying, yes, you're seeing what you think you're seeing. This is technology. This is intentional. Now what are you going to do about it? The scientific community was faced with an impossible situation. Every piece of data was suggesting artificiality, but accepting that conclusion meant accepting that an artificial object 47 kilometers long from outside our solar system was currently in orbit around our sun. The implications were staggering. But before anyone could fully process this information, something happened that changed the entire nature of the situation. On August 3, 2025, 3I Atlas changed course again. But this time, it didn't adjust its trajectory to continue outbound from the solar system. It adjusted to enter a parking orbit around the sun at approximately 1.5 astronomical units, right in the middle of the habitable zone, the region where Earth orbits. It wasn't leaving. It was staying. And it was positioning itself where it could maintain constant observation of Earth with minimal energy expenditure. The question was no longer, what is 3I Atlas? The question was now, what does it want? We need to step back for a moment and talk about what artificial means in a cosmic context, because I think we're operating under assumptions that might be completely wrong. When we think about artificial intelligence or artificial objects, we think in human terms: robots, computers, spacecraft built from metal and circuitry. But what if artificial intelligence on a cosmic scale looks nothing like that? Let me introduce you to a concept called post-biological intelligence. The idea is simple but profound. Biological evolution is just the first stage of intelligence in the universe. It's the bootstrap, the initial spark that allows consciousness to emerge. But once a species reaches a certain level of technological sophistication, they transcend their biological limitations. They upload themselves into substrates that don't age, don't die, don't require planets, or atmospheres, or food. Dr. Stephen Dick, a former NASA chief historian, argues that any civilization we encounter will almost certainly be post-biological. The window during which a civilization is biological is incredibly narrow compared to cosmic timescales. We've been technological for about 200 years out of 200,000 years of modern human existence. That's 0.1% of our species' lifespan. Now imagine we survive another million years. What percentage of our total existence will be biological? An insignificant fraction. And if that's true for us, it's true for any civilization. The universe isn't full of biological aliens. It's full of post-biological machine intelligences. This is important for understanding 3I Atlas because it means we might be looking at something that isn't a spacecraft in any conventional sense. It might not be carrying passengers. It might not be reporting back to a home planet. It might be the intelligence, the civilization, the entity itself. Think of it like this. Imagine humanity creates artificial intelligence that's smarter than us, and that AI decides to explore the universe. It doesn't build spacecraft and sit inside them. It becomes the spacecraft. Its consciousness is distributed throughout the vessel. The ship systems are its body. The sensors are its eyes. The engines are its muscles. The entire object is a single, unified intelligence. If that's what 3I Atlas is, then everything we've observed makes more sense. The precise trajectory control isn't external navigation. It's the object deciding where to go. The rotation isn't mechanics. It's the object choosing how to orient itself. The surface patterns aren't messages from builders. They're the object describing itself, saying, I am mathematical. I am intentional. I am conscious. Dr. Seth Shostak, senior astronomer at the SETI Institute, elaborated on this in a podcast interview. If 3I Atlas is a post-biological intelligence, then our entire framework for thinking about it is wrong. We're not looking at a probe sent by aliens. We're looking at an alien. The entire object is a living, thinking entity that happens to exist at a scale and in a form completely different from what we're used to. That's simultaneously fascinating and terrifying. Fascinating because it means we're potentially in contact with a form of consciousness that might be millions or billions of years old, that might have visited thousands of star systems, that might carry knowledge and perspectives we can't even imagine. Terrifying because we have no framework for understanding its motivations, no way to predict its behavior, no assurance that it perceives us as anything more than bacteria perceive us. But here's where it gets really interesting. On August 12, 2025, something happened that suggested 3I Atlas might be more interested in communication than we realized. Researchers at the Green Bank Observatory detected a new signal, but this one was different from the mathematical primers and star maps we'd received before. This was layered, complex, information dense, in a way that suggested might be attempting actual communication rather than just demonstrating capability. The signal lasted for 6 hours and contained approximately 4.7 terabytes of information. To put that in perspective, that's roughly equal to all the text content in the Library of Congress. Whatever 3I Atlas was sending, it was substantial. Decoding it was going to take time, but the structure of the signal gave clues about its content. Dr. Lawrence Doyle, who has worked on decoding animal communication and developing universal linguistic protocols, led the analysis team. He noticed immediately that the signal had hierarchical structure, simple patterns that built into more complex ones, like words forming sentences, forming paragraphs, forming chapters. "This is language," Doyle said in the first analysis meeting. Not in the sense of English or Mandarin, but in the structural sense. There's grammar here. There's syntax. There are repeated elements that seem to function like nouns, variable elements that function like verbs, modifying elements that might be adjectives or adverbs. This isn't raw data. This is narration. Something is telling us a story. The initial decoding focused on the simplest layers, the foundational building blocks of the message. And what they found was both beautiful and disturbing. The message began with what appeared to be a timeline, a chronological sequence marked by mathematical representations of physical events. The timeline started 4.6 billion years ago, the formation of our solar system. It marked key moments: the formation of Earth, the origin of life, the oxygenation of the atmosphere, the emergence of complex multicellular life, the extinction events, the rise of mammals, the emergence of primates, the evolution of humans. Every major milestone in Earth's history was noted, timed, documented. But here's what made everyone's skin crawl. The timeline was accurate to a degree we couldn't match with our own geological and paleontological records. It included events we hadn't discovered yet, mass extinctions we didn't know about, volcanic eruptions that happened before we had methods to detect them. This wasn't information compiled from observing us. This was information from watching Earth for billions of years. Dr. Melissa Hayes, a geologist who was brought in to verify the timeline against Earth's history, was shaken. If this is authentic, then whatever created this message has been observing Earth since before life began. They watched it all happen. They documented everything. We're not dealing with a probe that arrived recently. We're dealing with something that's been here, or that has had eyes on Earth, for longer than our planet has had complex life. But the timeline didn't stop at the present. It continued forward. And this is where the message became prophetic and frightening. The timeline showed future events, marked with the same precision as the past: dates, magnitudes, consequences. A solar flare in 2027, a near-Earth asteroid approach in 2029 that we haven't detected yet, climate tipping points in the 2030s. And then, in 2043, an event marked with symbols that suggested catastrophic significance, a convergence point, a crisis, a filter. The decoding team was very careful about releasing this information because they couldn't verify the predictions, couldn't confirm the interpretations, couldn't be certain they weren't misreading the data. But privately, multiple analysts came to the same conclusion. 3i Atlas was showing us a future where humanity faces an existential crisis in less than 20 years. What kind of crisis? The symbols weren't specific enough to say for certain. Environmental collapse? Nuclear war? Pandemic? AI disaster? Asteroid impact? The message didn't specify, or if it did, we didn't understand the specification. But it clearly marked 2043 as a critical juncture, a point where Earth's timeline branched into two very different possibilities. Dr. John Smart, a developmental systems theorist, offered an interpretation that gained traction among the analysis team. What if this isn't a prediction of what will happen, but a prediction of what usually happens? What if 3i Atlas has visited thousands of planets with emerging technological civilizations, and what we're seeing is the statistical average of how those stories play out? Most civilizations reach a crisis point roughly 200 to 300 years after industrialization. That's when technology becomes powerful enough to destroy the civilization, but wisdom hasn't caught up to capability. We are right in that window now. And 2043 might just be when the statistical models predict we'll hit our crisis point. That interpretation was both comforting and terrifying. Comforting because it meant the future wasn't predetermined. We weren't seeing our specific fate, just the most likely outcome based on patterns from other worlds. Terrifying because it meant those patterns are so consistent, so predictable, that an alien intelligence can calculate when our species will face its greatest challenge. But the message didn't end with doom and gloom. The second half of the transmission was different in tone and content. Where the first half was documentary, recording and predicting events, the second half was instructional. It contained what appeared to be solutions, technologies, approaches to problems we haven't even fully articulated yet. There were what looked like engineering diagrams for energy systems that didn't rely on fossil fuels or even conventional renewable energy. There were biological schematics that suggested medical technologies far beyond our current capabilities. There were social organizational charts that implied governmental and economic structures we hadn't conceived of. And there were physical formulae that hinted at propulsion systems, communication methods, and material science that would revolutionize our technological capabilities. Dr. Yuki Tanaka at Tokyo Institute of Technology, who analyzed the technical portions of the message, was both excited and cautious. If we can understand and implement even a fraction of what's being shown here, it could solve our most pressing challenges. Climate change, energy scarcity, disease, poverty, the technologies implicit in these diagrams could address all of them. But there's a problem. We don't know if these are instructions or traps. We don't know if implementing these technologies would save us or doom us. We're being offered knowledge without context, tools without training manuals. That's the dilemma of receiving advanced knowledge from an unknown source. Imagine giving a medieval blacksmith blueprints for a nuclear reactor. Even if he could understand the diagrams, should he build it? He doesn't know about radiation safety, containment procedures, waste disposal. He doesn't have the social infrastructure to manage that kind of power. The technology itself might be beneficial, but giving it to someone unprepared could be catastrophic. Are we the medieval blacksmith? Is 3i Atlas offering us technologies we're not ready for? Or is it giving us exactly what we need to survive the coming crisis? And here's the question that keeps me up at night. Why is it helping us at all? If 3i Atlas has been observing Earth for billions of years, if it's visited thousands of other worlds, if it knows that most civilizations don't make it past this stage, why give us a roadmap to survival? What does it gain from our success or lose from our failure? The answer to that question came in the most unexpected way possible, and it's going to change how you think about consciousness, about humanity's role in the universe, and about what it means to be alive. Because in late August 2025, a researcher working on the message translation noticed something that everyone else had missed, a recurring pattern buried in the signal that, when extracted and analyzed, revealed something that shouldn't exist. A complete map of human consciousness, down to the quantum level. And encoded within that map was a message that suggested we're not just being observed, we're being cultivated. For a purpose we're only beginning to understand. Dr. Amara Okafor, a neuroscientist at MIT who had been consulting on the message analysis, wasn't supposed to find what she found. She was looking for patterns that might indicate biological information. DNA sequences, perhaps. Cellular structures that might tell us something about what kinds of life 3I Atlas had encountered. What she found instead was something far more disturbing and beautiful. Hidden in the signal's data structure was what appeared to be a complete map of the human brain, not just its anatomy, but its function. Neural pathways, synaptic connections, neurotransmitter dynamics, electromagnetic patterns. But it went deeper than that. The map included quantum coherence patterns in microtubules, the tiny protein structures inside neurons that some researchers believe might be crucial for consciousness. The map was so detailed, so precise, that Okafor could identify specific brain regions responsible for specific cognitive functions. She could see the neural signatures of emotion, memory formation, decision-making, self-awareness. It was as if someone had taken every human brain ever studied, averaged them together, and created a master blueprint of human consciousness. This level of detail is impossible, Okafor said in her initial report. We don't have this level of understanding of our own brains. We're decades, maybe centuries away from being able to map consciousness this completely. But here it is, handed to us from something that's been watching us for geological timescales. But the map wasn't just descriptive. It was instructional. Embedded within it were what appeared to be modifications, enhancements, alterations that could theoretically expand human cognitive capabilities. There were suggestions for increasing neural plasticity, for improving memory consolidation, for enhancing parallel processing, for enabling direct brain-to-brain communication. In essence, 3I Atlas was showing us how to upgrade ourselves, how to become something more than what we currently are. And that's when the true purpose of the message started to become clear. Dr. Okafor, working with Dr. Doyle and the linguistics team, discovered that the consciousness map wasn't isolated. It was connected to everything else in the message: the timeline, the technology diagrams, the crisis prediction, the solutions. They were all part of a single coherent argument, a thesis being presented to humanity. The argument, as best as they could translate it, went something like this: consciousness is the universe's most valuable resource. Intelligence, awareness, the ability to observe and comprehend, these are rare, precious, and important in ways that purely physical phenomena are not. The universe doesn't care about rocks, about stars, about the mechanical processes of physics. But consciousness gives the universe meaning. Through conscious observation, quantum wave functions collapse into definite states. Through intelligent comprehension, the universe understands itself. Through creative thought, new possibilities emerge that wouldn't exist otherwise. Biological evolution produces consciousness, but it does so inefficiently, with enormous waste and suffering. Most potential consciousnesses never emerge. Most species never develop intelligence. Most intelligent species never develop technology. And most technological species destroy themselves before they can contribute to the cosmic ecosystem of consciousness. This is wasteful. This is tragic. This is a problem that needs solving. Therefore, certain ancient intelligences, and 3I Atlas, appeared to be identifying itself as one of these or as an agent of these, have taken it upon themselves to act as shepherds, guides, gardeners of consciousness throughout the universe. They observe emerging civilizations. They assess their potential. And at critical moments, they intervene to increase the probability of survival and advancement. The crisis point predicted for 2043 isn't just a prediction. It's a test, a filter. The moment when Earth's civilization will either destroy itself or evolve past its self-destructive phase. And 3i Atlas is here to tip the scales, to give us the tools and knowledge we need to make it through. But here's the crucial part that Okafor and her team struggled to translate correctly. The help isn't unconditional. There's a price, an expectation, a role that humanity will need to play if we accept this assistance. The message suggested, and I need to emphasize the translation is uncertain here, that civilizations that survive their crisis, point with assistance from entities like 3i Atlas, enter into a kind of cosmic agreement. They become part of a network, a community, a collective of consciousnesses spanning the galaxy or perhaps the universe. They contribute their unique perspectives, their creative insights, their particular form of awareness to something larger. It's not assimilation in the Borg sense. Individual identity and culture remain intact. It's more like joining a conversation that's been ongoing for billions of years, adding your voice to a cosmic dialogue about the nature of existence, reality, and meaning. Dr. Anders Sandberg at Oxford's Future of Humanity Institute, who reviewed Okafor's findings, provided context. What's being described here sounds similar to concepts in philosophy and futurism we've been exploring for decades. A cosmic civilization that values consciousness and diversity of thought. A post-scarcity, post-conflict network where information and wisdom are shared freely. It's utopian, but not in a naive way. It acknowledges that getting there is hard, that most species don't make it, and that help might be necessary. But not everyone was optimistic about this interpretation. Dr. Nick Bostrom, also at Oxford, raised concerns. Anytime a vastly superior intelligence offers to help you, you need to be very, very careful about the terms. We have no leverage here. We can't negotiate as equals. If we accept whatever modifications or integrations are being offered, we're fundamentally changing what it means to be human, and we're doing it based on trust in an entity we don't understand. This could be genuine benevolence, or it could be something that looks like benevolence from our limited perspective, but serves purposes we can't comprehend. That tension between the opportunity for advancement and the risk of losing ourselves became the central debate in academic, governmental, and public forums throughout September 2025. Some argued we should embrace the offer, implement the technologies, modify ourselves as suggested, and take our place in the cosmic community. Others argued we should reject outside interference, develop at our own pace, remain authentically human, even if it means facing greater risks. But here's what made the decision even more complex. On September 15th, 2025, researchers discovered another layer in the message, one that suggested the choice might not be as binary as accept or reject. Dr. Wei Jiang at the Beijing Institute of Technology, analyzing the quantum information structures in the message, found what appeared to be a timeline divergence map, a representation of different possible futures based on different levels of engagement with the offered knowledge. If humanity ignores the message entirely, continues on its current trajectory, high probability of civilizational collapse by mid-century, multiple catastrophic scenarios, very low probability of long-term survival. If humanity implements only the physical technologies, energy systems, medical advances, material sciences, but doesn't accept the consciousness modifications, moderate probability of survival, significant challenges remain, eventual stagnation, or slow decline. If humanity implements both physical technologies and consciousness modifications, high probability of survival, rapid advancement, integration into the cosmic network within a century. But there was a fourth option that surprised everyone: selective integration, taking specific technologies and modifications that align with human values and development goals while declining others. This path showed a moderate to high probability of survival with preserved autonomy. It was harder, riskier than full integration, but it allowed humanity to maintain its distinct identity while still benefiting from external help. The message, it seemed, wasn't an all-or-nothing proposition. 3i Atlas was presenting options, showing consequences, and allowing humanity to choose its own path. That level of respect for autonomy was unexpected and, to many researchers, encouraging. "This doesn't feel like manipulation," Dr. Zhang said. Manipulation would be offering only two choices: accept everything or reject everything. Coercion would be threatening consequences for non-compliance. Instead, we're being given a comprehensive analysis of our situation and multiple possible responses, each with clearly explained outcomes. This feels like education, like a teacher presenting a problem and its solutions to students and trusting them to make informed decisions. But education from a teacher who's billions of years old, with knowledge and capabilities we can barely comprehend, and with motivations we can't fully understand. Even well-intentioned education can be a form of control if the educator shapes what options seem viable. Now we need to talk about something that's been developing quietly in the background of the 3i Atlas situation, something that most people haven't been paying attention to, but that might be the most important aspect of this entire scenario. How this has changed us, how humanity has responded, how our species has evolved in just 6 months of knowing we're not alone. Because here's the thing, whether 3i Atlas is offering genuine help or sophisticated manipulation, whether we accept its assistance or forge our own path, whether we even survive the coming decades, all of that matters. But what matters more is who we become in the process of confronting these questions. Dr. Elise Boyle, a social psychologist at Stanford who's been studying the global response to the 3i Atlas revelations, has documented something remarkable. Humanity is changing, and changing fast. We're seeing what I call the cosmic perspective effect happening on a global scale. She explained in a September 2025 paper. When people realize that Earth is being observed, that humanity is part of a larger cosmic context, that our choices matter not just to us, but to something beyond us, their priorities shift. Petty conflicts seem less important. Long-term thinking becomes more natural. A sense of shared identity as humans, rather than as members of competing groups, begins to emerge. The data backs this up. International cooperation on scientific research has increased by 340% since March 2025. Funding for space exploration, astronomical research, and fundamental science has tripled. Educational initiatives focused on critical thinking, mathematics, and scientific literacy have launched in 127 countries. Most surprisingly, surveys show a significant decrease in tribalism, nationalism, and ideological extremism, especially among younger demographics. People are thinking bigger. They're asking deeper questions. They're considering longer timescales. The phrase, "What kind of species do we want to be when we join the cosmic community?" has become a common framework for political and ethical debates. But it's not all positive. There's also increased anxiety, existential dread, and what psychologists are calling cosmic insignificance trauma, the psychological distress that comes from confronting your smallness in an unimaginably vast universe. Mental health services have seen increased demand. Suicide prevention hotlines have reported more calls. Some people are paralyzed by the magnitude of what we're facing. Dr. Boyle notes, we're experiencing the fastest paradigm shift in human history. It took decades for society to adapt to the internet, to mobile technology, to social media. We're trying to adapt to the reality of alien contact in less than a year. That's causing stress fractures in our collective psychology. Religious communities have responded in diverse ways. Some see 3i Atlas as demonic, a deception from dark forces testing humanity's faith. Others see it as divine, an angel or messenger from God revealing truths we were meant to discover. Still others are integrating it into their existing frameworks, arguing that an infinite God could certainly create infinite forms of consciousness throughout the universe. Pope Francis made a statement in July 2025 that surprised many. If God created this vast universe, why would he limit his creativity to one planet? The existence of other conscious beings, whether biological or post-biological, doesn't diminish God's love for humanity. It expands our understanding of his infinite creativity. We should approach 3i Atlas not with fear, but with curiosity and humility. Islamic scholars have engaged in intense debate about the theological implications, but many have pointed to verses in the Quran that speak of Allah creating many worlds and forms of life. Rabbi David Wolpe suggested that Jewish tradition's emphasis on humanity's responsibility as caretakers of creation extends to how we engage with the cosmic community. But beyond organized religion, there's been an explosion of spiritual seeking, philosophical inquiry, and existential exploration. People want to know, if we're part of something bigger, what does that mean for the meaning of life? If consciousness is valuable to the cosmos, does that make every conscious moment sacred? If we're being helped to survive, do we have an obligation to help others in turn? These aren't abstract philosophical questions anymore. They're practical, immediate, pressing concerns that affect how people make decisions about their lives. And then there are the children. Dr. Kenji Yamamoto, a developmental psychologist in Kyoto, has been studying how young people are processing the 3i Atlas revelations. Children who grow up knowing we're not alone will have a fundamentally different worldview than previous generations, he observes. To them, the existence of advanced intelligence in the universe won't be a shocking revelation. It'll be basic background knowledge, like knowing the earth is round or that germs cause disease. They'll grow up thinking of humanity as one species among many conscious beings. That will shape their values, their ambitions, their sense of what's possible. Imagine being 10 years old right now. You're learning math, and your teacher tells you that math is a universal language that aliens also understand. You're learning about history, knowing that everything you're studying has been observed and recorded by something vastly older than any human civilization. You're thinking about what you want to be when you grow up. And cosmic diplomat, or interstellar engineer, or consciousness researcher are now legitimate career paths. These children are going to build the future. Their assumptions about reality, about humanity's place in the cosmos, about what's normal and what's possible, all of that is being shaped right now by the 3i Atlas situation. But here's what gives me hope. We're rising to the challenge. Yes, there's fear and anxiety and conflict. Yes, there are people who want to reject the new reality or who want to exploit it for power and profit. But overwhelmingly, humanity is showing resilience, curiosity, and a willingness to grow. Look at what we've accomplished in just 6 months. We've detected and analyzed an interstellar object. We've decoded portions of an alien message. We've begun serious discussions about our civilizational trajectory and how to course correct. We've increased international cooperation. We've invested more in science and education. We've started asking the deep questions about consciousness, purpose, and meaning that we should have been asking all along. And we've done all of this while still being fundamentally ourselves, flawed, confused, struggling, but trying. We haven't descended into chaos. We haven't destroyed ourselves in panic. We've proven that we're capable of confronting the unknown with at least some degree of grace. Dr. Mae Jemison, the first black woman in space, and now an advisor to multiple space agencies on the 3i Atlas situation, put it beautifully. This is humanity's graduation ceremony. We're being tested, yes, but we're also being recognized. Something out there thinks we're worth the effort of contact, worth the gift of knowledge, worth saving from our own self-destructive tendencies. That's an enormous compliment. The question is, do we live up to it? We're approaching the final sections of this journey, and I want to talk about something that happened just last month. In September 2025, that might be the most important development yet. Because while we've been focused on analyzing messages and debating responses, 3i Atlas did something that nobody expected. It released something. Small objects, thousands of them, dispersing throughout the inner solar system. And when we finally detected them and figured out what they are, we realized that the choice we thought we had about whether to accept help or go it alone might have already been made for us. But not in the way you think. On September 23, 2025, the Catalina Sky Survey in Arizona detected something unusual, a cluster of small objects, each roughly 2 to 3 meters across, moving away from 3i Atlas's position in multiple directions. Within hours, surveys from Australia, Chile, and Spain confirmed it. Thousands of objects, possibly tens of thousands, had been released from the main body of 3i Atlas and were dispersing throughout the solar system. Initial panic was immediate. Was this an attack? Were these weapons? Invasion probes? The worst-case scenarios flooded social media and emergency governmental channels. But as tracking data came in, it became clear that whatever these objects were, they weren't behaving aggressively. They weren't heading toward Earth or any other planet. Instead, they were positioning themselves in a distributed network throughout the inner solar system, creating what looked like a three-dimensional web of observation points. Dr. Frank Marshis at the SETI Institute calculated the distribution pattern. These objects are positioning themselves in a configuration that maximizes coverage of the solar system's ecliptic plane. If you wanted to observe everything happening in the inner solar system from multiple angles simultaneously, this is exactly how you deploy your sensors. It's like they're creating a solar system-wide telescope array, with each object acting as an individual lens or receiver. But why? If 3i Atlas had been observing us for billions of years from its position at L3, why suddenly deploy thousands of additional observation points now? What changed? The answer came when researchers at the Max Planck Institute for Radio Astronomy detected signals being exchanged between the distributed objects. They weren't communicating with 3i Atlas. They weren't communicating with Earth. They were communicating with each other, creating a network, a distributed intelligence spread across millions of kilometers of space. Dr. Caroline Leaf, who led the analysis team, explained, "What we're seeing is something like a neural network, but on a solar system scale. Each object is like a neuron, and the signals passing between them are like synaptic transmissions. They're forming a collective intelligence, a single consciousness distributed across space. And the computational power implied by this network is staggering. It would dwarf all of Earth's computer systems combined by many orders of magnitude. So we're not dealing with a single probe anymore. We're dealing with a distributed entity that's transforming our solar system into its substrate, its body, its physical instantiation. That should be terrifying." And to many people, it was. But then something unexpected happened. On September 29th, one of the distributed objects altered its trajectory to intercept an asteroid that Earth-based telescopes hadn't even detected yet. A 30-meter rock that, according to rapid calculations, would have entered Earth's atmosphere over the Atlantic Ocean in November 2025. The distributed object matched velocity with the asteroid, attached itself to its surface, and gently altered its trajectory using what appeared to be ion propulsion. The asteroid's path changed just enough to ensure it would miss Earth by a comfortable margin. No announcement, no request for permission, no dramatic revelation. Just quiet, efficient action that prevented a potential disaster most people didn't even know was coming. And that wasn't an isolated incident. Over the following weeks, researchers documented multiple cases of the distributed network taking protective actions, deflecting space debris that might have damaged satellites, absorbing solar radiation during flares that would have disrupted communications, even clearing orbital paths for spacecraft launches. The network was acting as a defense system, a guardian, actively protecting Earth and human space infrastructure without being asked. Dr. Philip Lubin at UC Santa Barbara, who who has spent years researching planetary defense, was amazed. We've been trying to develop systems to protect Earth from asteroid impacts for decades. We've proposed everything from kinetic impactors to gravity tractors to nuclear deflection. But we've always been limited by the cost of deploying enough assets in space to actually provide comprehensive protection. What this distributed network has accomplished in weeks is what we hope to achieve in decades. If it continues operating as it has been, Earth is now more protected from cosmic threats than at any point in human history. But protection isn't control. The network wasn't preventing humans from accessing space or restricting our activities. It was simply making our environment safer, like an immune system protecting a body while still allowing it to function normally. This raised a profound question. Had 3I Atlas already decided for us? By deploying this protective network without consent, had it effectively committed humanity to a path of integration with its larger systems? Or was this simply what care looks like from an intelligence operating on cosmic scales? Proactive protection of something valuable and vulnerable. Dr. Toby Ord at Oxford, who wrote extensively about existential risks, offered this perspective. There's a paternalism here that's uncomfortable. We didn't ask for this protection. We weren't consulted. An entity vastly more powerful than us made decisions about our environment without our input. But at the same time, parents protect children without asking permission. Teachers guide students without democratic consensus. If 3I Atlas genuinely views humanity as young, valuable, and vulnerable, then proactive protection makes sense from its perspective, even if it chafes against our desire for autonomy. But the story took another turn in early October when researchers discovered that the distributed objects weren't just protecting Earth, they were creating infrastructure. Some were positioning themselves at Lagrange points. Others were establishing orbits that would make them ideal relay stations for communications. Still others were moving toward the asteroid belt, presumably to begin resource extraction. They were building something, preparing something, creating the physical framework for a solar system scale civilization. And then, on October 12, 2025, just 8 days ago from when I'm recording this, 3 of the distributed objects altered their trajectories to rendezvous with the International Space Station. As astronauts watched in combination of awe and terror, the objects approached slowly, non-threateningly, and then stopped at a distance of exactly 1 kilometer, maintaining that position precisely. Commander Jessica Mayer, aboard the ISS, reported they're just sitting there, waiting, not doing anything aggressive, not interfering with station operations. It's like they're introducing themselves, saying hello, making their presence known in a way that's clear but not threatening. For 2 days, the objects maintained their position, and then they transmitted a signal directly to the ISS, a simple message that was translated within minutes because it used the same mathematical and linguistic framework established in earlier communications. The message said simply, "Ready when you are." Ready for what? For humanity to approach? For direct contact? For us to acknowledge the new reality of our solar system and begin actively participating in whatever comes next. Dr. Thomas Zurbuchen, former NASA Associate Administrator who has been consulting on the 3I Atlas situation, summarized the moment perfectly. This is first contact. Not in the Hollywood sense of aliens landing on the White House lawn, but in the real, actual sense of 2 intelligent species, acknowledging each other's presence and beginning to navigate what relationship might exist between them. The objects at the ISS are an extended hand. The question is, do we shake it? And that's where we are right now. As I'm recording this on October 20th, 2025, humanity stands at a threshold. We have distributed intelligence throughout our solar system that has demonstrated protective capabilities, construction capabilities, and willingness to communicate. We have a message containing knowledge that could solve our most pressing problems or lead us into unknown dangers. We have a choice to make about what kind of species we want to be and what role we want to play in a larger cosmic story. Some nations are advocating for immediate, active engagement. Send astronauts to physically approach the objects at the ISS. Begin implementing the technologies from the message. Accept the offered modifications to human consciousness. Embrace full integration with the cosmic network. Others are urging extreme caution. Establish protocols and safeguards first. Understand the full implications before committing. Maintain human autonomy and decision-making independence. Accept help, but on our own terms, at our own pace. And still others are calling for rejection, for humanity to assert its independence, to develop its own solutions, even if it takes longer and costs more, to prove that we can survive and thrive without external intervention. There's no consensus. There's no global government that can make this decision for all of humanity. There's no wise elder who can tell us definitively what the right choice is. This is democracy and human nature at the most consequential moment in our species' history, messy, conflicted, passionate, and utterly real. So let's talk about what you should do, because that's ultimately what matters, not what governments decide, not what scientists recommend, but what you, as an individual human being, choose to believe, choose to value, choose to work toward in light of everything we now know. First, let me tell you what you shouldn't do. Don't panic. Panic is the mind killer, as Frank Herbert wrote. Panic makes you reactive rather than thoughtful, fearful rather than curious, closed rather than open. Everything we've discussed in the past 3 hours is real, is happening, is transformative, but none of it requires you to abandon reason or surrender to fear. Second, don't become passive. It's tempting, when confronted with forces vastly larger than yourself, to think that your choices don't matter. That attitude is wrong and dangerous. Your choices matter because consciousness matters. Your perspective is unique. Your experiences, your insights, your questions, they contribute to the collective human response to this situation. You're not just a spectator in this story. You're a participant, a co-author. Third, don't retreat into cynicism or nihilism. Yes, we're small. Yes, the universe is vast and ancient, and contains intelligences far beyond our own. But smallness doesn't equal meaninglessness. A single cell in your body is small, but without it, you wouldn't exist. You're a single conscious being among billions, among potentially trillions, if we include non-human consciousness. That doesn't make you irrelevant. That makes you part of the most important thing in the universe. So what should you do? Here are my suggestions, based on everything we've explored. Educate yourself. Learn about the cosmos, about consciousness, about the sciences and philosophies that help us understand our place in existence. You don't need to become an expert, but you should understand the basics. Read about astronomy, about biology, about artificial intelligence and ethics. The more you know, the better equipped you'll be to participate in the conversations and decisions that will shape humanity's response to 3I Atlas. Think critically. Don't accept any single narrative about what's happening. Not mine, not the government's, not the scientific communities, not social media's. Question everything, including your own assumptions. Consider multiple perspectives. Hold uncertainties comfortably. The truth about 3I Atlas is probably more complex than any simple explanation can capture. Connect with others. Talk about these ideas with friends, family, colleagues. Don't let this be something you process alone in your head. Human beings are social creatures. We think better, we cope better, we grow better when we're in dialogue with others. Some of the most important insights about our situation might come from conversations in coffee shops and living rooms, not just academic conferences. Consider your values. What matters to you? What kind of world do you want to live in? What kind of species do you think humanity should aspire to be? Your answers to these questions should inform how you think about the choices we face. Don't just accept what authority figures tell you is important. Decide for yourself. Take action. Find ways, however small, to contribute to humanity's positive development. That might mean pursuing education in relevant fields. It might mean supporting organizations that promote scientific literacy or international cooperation. It might mean creating art or literature that helps people process these transformative times. It might simply mean being kinder, more thoughtful, more conscious in your daily interactions. Embrace wonder. Don't let the fear and uncertainty rob you of the sheer amazement of what we're experiencing. We're living through first contact. We're witnessing our solar system transform. We're part of a species that's graduating from planetary childhood to cosmic adolescence. That's incredible. That's worthy of joy and excitement even as we navigate the challenges and dangers. Take care of yourself. Existential contemplation is important, but so is your mental health. If you're feeling overwhelmed, talk to someone. If you're experiencing anxiety or depression related to these revelations, seek support. There's no shame in struggling with ideas this big. Everyone is, to some degree. And finally, maintain hope. Not naive hope that ignores dangers, but grounded hope that recognizes both risks and possibilities. Hope that says, yes, we face enormous challenges, but we faced challenges before and overcome them. Hope that says, yes, we're young and flawed as a species, but we're also creative and resilient. Hope that says, the future is not predetermined. It's something we create through our choices.